Let us today discuss the graphs. A graph is a non-linear data structure consisting of nodes and edges. The nodes are sometimes also referred to as vertices, and the edges are lines or arcs that connect any two nodes in the graph. The definition of graph is as follows. A graph consists of a finite set of vertices or nodes and a set of edges which connect a pair of nodes. Consider the following presentation on the slide. The arrows indicate the edges of the graph and the circles indicate the vertex of the graph. The figure is a classic example of a simple graph. Graphs are categorized into two types which include undirected graphs and directed graphs. This slide has two pictures which indicate the different types of graphs. In simple words, an undirected graph is a graph with no arrays indicating no direction, and the directed graph is a representation with arrows indicating a certain direction. In an undirected graph, nodes are connected by edges that are all bidirectional. For example, if an edge connects node 1 and 2, we can traverse from node 1 to node 2 and from node 2 to node 1. In a directed graph, nodes are connected by directed edges. They only go in one direction. For example, if an edge connects node 1 and 2, but the arrowhead points towards 2, we can only traverse from node 1 to node 2, not in the opposite direction. As we can see in this slide, graphs can be further represented using any of the two methods. First using adjacency matrix and the second using adjacency list. Adjacency matrix. An adjacency matrix is a 2D array of size v cross v where v is the number of nodes in a graph. A slot matrix of I rows and j column equal to 1 indicates that there is an edge from node I to node j. Adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. To create an adjacency list, an array of lists is used. The size of the array is equal to the number of nodes. There are wide ranges of advantages and disadvantages of graph. Some advantages include the adjacency matrices are helpful when we need to quickly check if two nodes have a direct edge or not. The adjacency matrix is most helpful in cases where the graph doesn't contain a large number of nodes. Adjacency matrix can be a great solution when the graph is incomplete. Adjacency lists are a great option to continuously access all the neighbors of same node U. Apart from this, they are easy to represent and simple to understand. There are certain disadvantages of graphs which include large memory complexity, time-consuming and complex for large data. Interpretation can become difficult. Graphs have very wide range of applications which include maps and road charts, activity network diagrams, state transition diagrams, and program flow.